Output. The above code generates the following output. Use TF global variables, initialize instead. TensorFlow core platform. CPU supports instructions, that is TensorFlow binary was not compiled to use AVX2. EPOCH 1 to up to 25. Cost also according to that. So training phase finished. Model accuracy 0.9135. The logistic regression is considered as a predictive analysis. Logistic regression is used to describe data and explain the relationship between one dependent binary variable and one or more nominal or independent variables. Logistic Logistic regression training phase. Approach in x-axis, cost in y-axis. So graph points we got like this. Okay. So next chapter for TensorFlow, linear regression. In this linear regression, in this chapter, we will focus on the basic example of linear regression implementation using TensorFlow. Logistic regression or linear regression is a supervised machine learning approach for the classification of ordered discrete categories. Our goal in this step is to build a model by which user can predict the relationship between predictor variables, one or more independent variables. Logistic regression or linear regression is a supervised machine learning approach for classification of ordered discrete categories. The relationship between these two variables is considered linear if y is dependent variable and x is considered as independent variable. Then the linear regression relationship of two variables will look like the following equation: y equal to ax plus b. We will design an algorithm for linear regression. This will allow us to understand the following two important concepts: cost function, gradient descent algorithms. The scheme representation of linear regressions is mentioned below. Interpreting the result y equal to ax plus b. The value of a is the slope. The value of the p is the y's intercept. R is the correlation coefficient. R square is the coefficient of determination. X-axis, y-axis, so. Okay. Y equal to x plus b. Steps to design an algorithm for linear regression. We will now learn about the steps that help in designing an algorithm for linear regression. Step 1. It is important to import the necessary modules for plotting the linear regression module. We start importing the Python library numpy and the matplotlib. Import numpy as np, import matplotlib pyplot as plt. This one. Step 2. Define the number of coefficients necessary for logistic regression. number of points 500, x point, y point, a equal to 0.02, p equal to 0.78. Step 3. Iterate the variables for generating 300 random points around regression equation. Y equal to 0.22 x plus 0.78. For I in range, number of points x equal to np random normal 0, 0.5, y equal to a multiple x plus b plus np random dot normal 0, 0.1, x point append x, y point append y. Step 4. View the generated points using matplot library. Plot x point, y point, 0 label output label input data O for output, plot legend, plot show. The complete code for logistic regression is as follows. Import numpy as np, import matplot library by plot as plot, number of points 500, x point, y point, a equal to 0.22, p equal to 0.788. For I in range, number of points x, np random normal 0, 0.5, y equal to ax plus p plus np random normal 0, 0.1, x point append of x, y point append of y. Plot x point, y point, output level input data. Plot legend, plot show. The number of points which is taken as inputs considered as input data. Input linear regression. Linear regression. Then on next one chapter, TF-LAN and its installation. TF-LAN can be defined as a modular transparent pre-planning aspect used in TensorFlow framework. The main motive TF-LAN is to provide higher level API to TensorFlow for facilitate and showing up new experiments. Consider the following important features of TF-LAN. TF-LAN is easy to use and understand. It includes easy concepts to build highly modular network layers, optimizers, and various metrics embedded with them. It includes full transparency with the TensorFlow work system. It includes powerful helper functions to train the built-in tensor which accept multiple inputs, outputs, and optimizers. It includes easy and beautiful graph visualization. The graph visualization includes various details of weights, gradients, activation. Install TF-LAN by executing the following command: pip install TF-LAN. Upon execution of the above code, the following output will be generated. Command prompt TensorFlow project pipe install TF-LAN, collecting TF-LAN, using cached HTTP files, Python hosted or packages system easy like this. requirement already satisfied. NumB and C plan requirement satisfied. 6 in C, below in C, T plan done, running setup, done. 5% PIP version 18. However, version 8.1 is available. You should consider upgrading via Python m-pipe install upgrade pip command. The following illustration shows the implementation of TF-LAN with a random forest classifier from feature import division, print function, absolute import, TF-LAN module implementation, import TF-LAN from TF-LAN estimators, import random for ST classifier, estimator classifier, EST classifier, data loading and pre-processing with respect to dataset, imported TF-LAN datasets MNIST as MNIST. XY test X test Y equal to MNIST, load data 1 port equal to false, M equal to random for classifier, N estimators 100, maximum nodes 1000, M fit of X Y batch size 10,000, display step 10, print compute the accuracy on the train data, print M evaluate XY test plan accuracy of print compute the accuracy on the test set, print of M evaluates test X, test Y, TF-LAN accuracy, print digits for test images ID 0 to 5, print M dot predict test X 5, print 2 digits, print test Y 5. The next one, CNN and RNN difference. In this chapter, we will focus on the difference between CNN and RNN. It is suitable for spatial data such as images. It is suitable for temporal data, also called sequential data. CNN is considered to be more powerful than RNN. Includes less feature compatibility when compared to CNN. This network takes picture size inputs and generates picture size outputs. RNN can handle arbitrary input-output lines. CNN is a type of feed-forward artificial neural network with variations of multi-layered perceptrons designed to use minimal amounts of preprocessing. RNN, unlike feed-forward neural networks, can use their internal memory to process arbitrary sequence of inputs. CNN use connectivity pattern between neurons. This is inspired by the organization of animal visual cortex, whose individual neurons are arranged in such a way that they respond to overlapping regions tiling the visual field. Recurrent neural networks use time series information. What a user spoke last will impact what she will speak next. CNN are ideal images and video processing. RN are ideal for text and speech analysis. Following illustrations shows the schematic representation of CNN and RNN. Input frame in CNN is